King Mohammed Al-Qasimi, member of the Supreme Council and ruler of Sharjah, the park aims to create a dynamic ecosystem that fosters innovation, entrepreneurship, and collaboration among businesses, academia, and research institutions. SRTIP provides, as you maybe have seen or you will see afterward, state-of-the-art infrastructure and facilities for research and development, innovation, entrepreneurship, and knowledge transfer in various fields such as renewable energy, environmental technologies, digital technologies, and advanced manufacturing. The park is the home of diverse community of businesses, startups, and offers a range of services and programs to support the growth and development. So with this strategic location, we are here next to University City with more than 22 university and institution. We are surrounded by more than 47,000 students, and I think it's more than 2,000 PhDs. So with our world-class facilities and this innovative ecosystem, SRTIP Park is leading destination for businesses and researchers seeking to drive innovation and make a positive impact on society. Now, I would like to maybe draw the attention on what is the topic of today. It's one of our park unique offering, our additive manufacturing hub. We are really proud to be, I think, the only additive manufacturing hub in the region. And this gives us a distinct advantage. Additive manufacturing is a revolutionary technology that has transformed the manufacturing industry. And we are at the forefront of this innovation. Our additive manufacturing hub offers a wide range of materials, from plastic to metal, that can be used to create various products, from prototypes to end-use parts. We also host the most cutting-edge equipment in additive manufacturing and partner with industry leaders like 3DT, Farsoon, GE, Ceterox, and Creality. One of the main advantages of 3D printing is its ability to produce complex and customized designs quickly and efficiently with minimum waste. This makes it an ideal solution for businesses looking to reduce their production costs and increase their speed to market. At SRTIP Park, 3D printing hub or additive manufacturing, we are really confident that our expertise in 3D printing and additive manufacturing can help further push this technology in the region. So this is today the subject of our tech talk, and I'm very happy to have a panel of experts with whom we'll explore the trends which will step the future, the future of additive manufacturing. Sorry. So before starting, I will just show you a short video of the park so you have a better idea, and then we will call on stage our moderator and panelists. You're supposed to have the sound, but sorry, I can't sing. I think this short video shows a lot about all opportunities that you can find here. So now I would like to call on stage our moderator of the day. It will be Haider. Please come and join me on stage. Haider is the project executive of Middle East Engineering Technology, so expert in additive manufacturing, and you will call and invite on stage our expert and panelists today. Thank you.
Hello, good morning, ladies and gentlemen. So yeah, I'm Haider al-Haidari, and hopefully we are going to have an interesting discussion today about 3D printing. Technology, as you all know now, is the lifeline of our economy. It's never stopped, and it's never going to stop. And we need to continue learning and expanding our horizons when it comes to technology and the latest in this field. 3D printing as a technology was a natural progression of the technological life of the economy. We started in the late 1700s, for example, with the first industrial revolution, where we learned how to make machines. And then 100 years later, we learned about electricity, and we learned to electrify those machines. And then we learned in the 1960s, we learned how to automate those machines. And that created factories, mass production, and industries really wanted to produce a lot of products and send it out to the market because, well, it's economically feasible, but they had one problem, and that is, how do they know that the market is going to buy those products? So they needed a solution to quickly test whether a product was going to be a successful product or not, and that's when they came up with 3D printing as a rapid prototyping technology. And that did not stop there. It continued to evolve until today. We have Industry 4.0, and we have a lot of techniques of 3D printing. And I would like to call upon our panelists, our panel of experts for today, to talk more about 3D printing and to talk more about this evolution of 3D printing technology in general and how it is still the lifeline of our economy, and it will continue to be so. So first and foremost, I would like to welcome Murad Muntasir, the co-founder of CRP Gulf, to the stage. Can we have a round of applause, please? Next, I would like to welcome Peter Arkham, founder and CEO from Proto 21. And finally, I would like to welcome Vito Zaccaria, CEO of Solid Energy and Solid Power. Thank you for joining me, ladies and gentlemen. Welcome. First of all, I know my introductions were a bit weak, so I'd like you to take the opportunity to introduce yourselves. I'm sure you'll do a much better job than I would.
Yeah, thank you for inviting me. Thank you for being here. Good morning, everyone. Ladies and gentlemen. Yeah, very quickly, born in Morocco, raised up in Italy. You can feel my accent. It's something I cannot hide anymore. Then, I have now more than 15, 17 years experience in technology, and a few years back, I was crazy enough to move in the region, and with some partners, we decided to bring the technology additive manufacturing, especially in composite material, high-spec material, and to target some high industry, oil and gas, automotive, aerospace. And here we're trying to do our best. Alhamdulillah, it's a good business, good market, and this awareness conference like this TikTok has helped us to promote and to push this technology to the limit and beyond. Thank you.
Hello guys, so my name is Pete Arthur, and I'm the founder and CEO of Proto 21, 3D Printing LLC's service bureau in Dubai, one of the fastest growing. My journey is quite long, and currently, as if I started my journey in 2012 in 3D printing. I saw the first 3D printing as a fresh graduate in the United States on a scholarship. That time when I saw it, I couldn't believe it's something that can do some model out of space. And since then I was intrigued of the technology and I just took it as a final year project while my bachelor's. After that, I made the first 3D printer in Pakistan in 2012 in the early times. After that, I went across masters abroad in Germany, Turkey, and Spain. And then I came back to the home country, Pakistan, but the startup failed there. So I then came to Dubai to look for a job. And when I came to Dubai for a job, I joined as a salesperson to one of the companies. And then soon I realized that I want to start my own again here in Dubai. So I took a leap of faith and resigned the job and started from my baddest space. So I had a small printer in my room, literally, and I built a website. Started my journey there. Then I was lucky enough to find good people, good partners, and today we are one of the largest 3D companies in this market.
Hello. Hello, good morning, everyone. My name is Vito Zaccaria. I'm half Italian, half German. Now I live here in the UAE. And my experience started 15 years ago after I degree in Mechanical University of Bologna. And in Italy, we have now it's one of the biggest European company for Industry 4.0. It means it's not only additive manufacturing, it's also robotics, it's automations, it's virtual reality, it's everything what covers the future of the industries. So we have more than 8,000 customers only in Italy. Just to give you some names, it's Ferrari, Lamborghini, but not only mechanics, we have also Prada, Gucci, because also these companies are using 3D printers. I will explain you later something about fashion, because I saw a lot of ladies. Yeah, so 1 year ago, I opened also the company here in the UAE, and our mission is to not only to sell the 3D printers, because of course we also resell printers, but our goal is taking customers, taking the companies by hands and help them to grow in the additive manufacturing field. This is what we can do very well. Not only selling, we help the companies. Thank you.
Thank you, gentlemen. Very interesting story. Before I get into the meat of the discussion, here you mentioned something quite interesting. You said you took a leap of faith when you started your own company. What did you see? I mean, we're talking about the spirit of technology and how it is the future. What did you see when you decided, yes, I'm going to risk it all, I'm going to start my own company in 3D printing?
To be very honest, Pursuit of Happiness. Has anybody seen a movie? Pursuit of Happiness?
Ah, yes, we do.
That changed my life. There's a one quote there. I was literally in my bed at night, 11 p.m. And I was going through this, and I just felt like I can do it. It's my time. I had failed once. Now it's a good country. I can make it work here. And I said, when I will do it. Like, I've been thinking about it. The logo which I have for the 21 is around, I sketched it out in my final year when I was in the back seats in my club. I was here in the back seat too. So when I was in my college, I used to sketch that logo, and my logo is that old. So I want to make that company the largest 3D printing company in the world. That's my vision and goal of life. I said, when I will do it, I'm 26 now, and I need to start somewhere. Okay, I'll fail again, because I literally had no money. I had no investor. I was on my own. I came to Dubai with 1,600 dirhams in my pocket. That's all. I just literally ran out of my country, out of disappointment, came to this country with just 1,600 in my pocket. The next morning I woke up, that day I remember, I was checking on the menu for the breakfast. There was the cheapest, on the right side of all the figures, right? And I said, I have nothing else to lose. So, I mean, I'm having a job, it's a comfort zone, I just don't enjoy it. And that ex-company is still my good friend, so we work together, right? We have a great relationship. So I said, if I don't do it now, I'll never do it. So I just, resigned, sent an email, and I just spoke to them. I told them I'm going to start my own company. and I just moved on. And I just started from my bedroom. I said, what I can do, I started with training courses because I was good in knowledge.
That's quite interesting. And it really shows that, you know, taking a leap of faith or basically investing in technology is going to pay off. I mean, like, this is the whole point of the SRTIP. We're trying to bring technology to the forefront because we believe in it. We do believe that this is going to be the future. Let's get warmed up a little bit with 3D printing. So my first question to the panel, maybe I'll start with Murad, is what is additive manufacturing? What is 3D printing? Are they synonyms of each other? Is there a difference?
If you consider globally, there are a lot of misunderstanding about the technology, because today people, they think they can print everything. You can see in the media, they want to print on the first mosque, they want to print the house, they want to print cars, vessel, anything they can, their mind, they think they can be printed. It's half true. I mean, the technology helps you to print a lot of components in this case, but how to do it, where to do it, in again, is something different, and we need to target a different industry. Then this is 3D printing. Additive manufacturing is something should be where you bring the conventional manufacturing today, because we know it, and we add value. And this is again something different. In some application, again, I can consider they are synonymous, and others really they are complementary. And today, people again, without going much deeply, I just give an overview. It's moving more and more in 3D printing, not in additive. But again, when we talk about medical and aerospace, yes, they do additive manufacturing. And if we want to wait to see where it's going, it will be too late. As I was mentioning, we're always going to print bigger, and we need to see where we're going in the end of the outcome of this technology. And I remember when I started, really was half material what we see today in the market, and again, half application. And today, big names, they're driving this business because they put in a lot of money, and they have a high expectation, and especially when the government expecting to make way the hub of 3D printing in all GCC globally. And it's the right place to be. This is the right place when you're thinking. But again, it takes a lot of effort and energy.
Yes.
What I think is that additive manufacturing gives to the young generation very good opportunities, because in the manufacturing companies, there are, let's say, also old technologies, not old, let's say traditional technologies like CNC milling machine, turning machines, and the experts, of course, are the old employees. 3D printing is something new. It's opposite. The old people, the old employees doesn't know how to use 3D printing, but the young generation knows. So it gives us, for this reason we are young, because it's a new technology, let's say a new technology, and it gives us very good opportunities.
Vito, I mean, I love what you're saying, but can we take a step back and can you explain to the audience, just to set the basis, set the foundation? What is additive manufacturing? Compared, you mentioned CNC milling, traditional manufacturing. What's the essence of additive manufacturing of 3D printing?
Yeah, let's say the traditional way is called subtractive manufacturing. It means I start from a material that is like a block, and I have to remove material. And removing material means having waste, having a lot of material that I don't use anymore. It's only for doing this shape. Okay. With additive manufacturing, it's opposite. I use only the material that is needed. So it's a green technology. It's a sustainable technology. And yeah.
I mean, there are also a lot of techniques when it comes to 3D printing. 3D printing is a general term that encompasses a lot of different techniques, a lot of printers. We have, for example, the FDM, SLA, lots of acronyms in this field. What are the most prominent ones, in your opinion? Maybe I'll start with Murad and move upwards. What are the most prominent techniques, 3D printing techniques in the industry today that we need to know about?
It's a very open question. It's more the easy technology is 3D printing today is FDM. Because again, it's the most cheaper, it's more easy to use, and I think all universities and schools soon they will have it. And my vision is to see designed for the 3D printing. Then if you move to the industry, yes, they have high expectation. Then another technology is SLS, SLM, direct energy deposition, a lot of acronyms. And today the industry is looking for different materials. Then we need to identify technology where you can use polymer, plastic, carbon fiber, aluminum. Again, I can make a list of different materials. When we move in metal, you can print gold, you can print platinum, you can make chrome. Again, a lot of different materials we use in different sectors. Then it's very open question to understand really who our target customer, and based on that we can identify what's the best technology for the market. And for me today, when it's moving, is always trying to understand print value is a high material, because the technology starts to be a little bit old, as Vito was mentioning. It's almost new, 30-35 years in the market. What is more challenging today is to find new material, combine different materials. Give an example, when you can add the titanium, strength with aluminum line, and you have titanium aluminum, and this is something that's powerful, iron-based, and so on. Is also in composite. You can print carbon fiber, and you can have very light and strong material for different applications. This go really from fashion, from medical, from even personal use. Anyone can take advantage of this technology with different materials.
You mentioned the FDM printers are very common now because they're in the homes, they're in the schools, everybody's using it. Besides FDM, what other printer what other printer would you say is prominent currently being used?
When you say prominent, it's like most popular, right?
Yes.
Okay, so the most popular 3D print. So first of all, I want to give a small idea of 3D printing and additive manufacturing. Then I'll come back to this with it, okay?
Please, yes, absolutely.
So we industrialists or we experts in 3D printing do not use the word 3D printing. We use additive manufacturing because that's the right term to be used. 3D printing, the term, is misguided. Additive manufacturing is the right term to use. Why? Because there's this, like our colleague said, there's subtractive manufacturing. So just to understand 3D printing, the best way is to say how the things were made without 3D printing. How was this table made before 3D printing came into being? How this furniture was made? It was made with a block of material, let's say wood, any material, plastic or not plastic, but wood, metal or something. You carve out a shape of it, out of it. But in additive manufacturing, you don't have a block of wood to start from. You start from a layer, and another layer is on top, and just like that, a full model is created. So additive manufacturing is a more right term to be used. Now, what technology is most prominent? Coming to your question. The first technology that came into being in 3D printing was SLA, serial lithography. So that technology is usually, if you see in dentists, you will see they use 3D printers a lot. That's one industry that's actually used by the professional, not having a 3D printing engineer running for it. So in dentistry, they have this kind of a machine which has an orange case. Has anybody seen some? Like a 3D printer in any dentist, if you ever visited? So they have a machine which is having a liquid and a laser, which is printing layer by layer, upside down, any model. When I say upside down, it's a common one. That is the first technology came into being. The most popular, well, that is liquid and then laser, a little complicated. So it's not common in the normal market. When we have normal market, when I say in schools and colleges, students, research enthusiasts, and people, children have them in the home. There's an FDM technology, which is the most simplest. Most of us have done baking sometimes. You squeeze out when you write happy birthday on top of a cake, right? The easiest way to explain the FDM technology is that. So
You just explained extrusion in general.
Yeah. When I used to give training courses, I used to use this kind of explanation to explain it. So you have a plastic string that you literally heat and you make a shape on it. That's how simple you can explain 3D printing FDM technology. So that's the most prominent for the sake it's not dangerous. You have a PLA material used there, which is polylactic acid, and it is made out of cornstarch and it is biodegradable. I mean, no plastic ever. If anybody says plastic is biodegradable, there's something not right there. It's the most possible percentage of biodegradable possibility there, and that's current material. So the most prominent, as I see, is FDM technology in the market. It is, let's say, in Product 21, we have, where we have now 60 machines. Yeah, 60 FDMs in our company right now. So it's most prominent in my service bureau, and it's also most common in most of the service bureaus you see around the market, and very common in the people's homes and labs and schools.
Yes, and there are also other technologies. For example, PolyJet. PolyJet is a full color 3D printer, and it's the only technology that can print also on fabric. For this reason, for example, in Italy, Gucci and Prada are using this printer for directly print on fabric. So this is something that with other technologies, traditional technologies is not possible to do. With additive manufacturing, it's possible. You can see with the phone, additive manufacturing, fabrics, fashion, you can see lots of pictures. And the other one is the future, but it's not, it's the reality. It's 3D printers for healthcare. We have 3D printers that allows to 3D print, or better, to extract from the X-ray of the patient at the hospital. We can extract, for example, the bones or the liver or the heart of the patient. We can 3D print the part, full color, and with the same hardness also. And the doctors can use this 3D printer model for doing the surgical simulation. So before opening the patient, they can simulate the operation on the table. And we also have worldwide the only printer that can print skin. So there are two extruders. One prints like a scaffolding, it's a biocompatible scaffolding, and the other prints stem cell. So it means I can, from the patient, I can remove a little bit of my cells, okay, I let it grow, and the 3D printer can use the cells for 3D printing tissue. So this is, let's say, it's happening.
The technology that's there.
Yeah, it's there. We announced the first 3D printer 2 months ago in Italy, and let's say this is the future also of additive manufacturing. Not only mechanics, but also fashion, most important, healthcare.
Absolutely. You know, you're talking about dentistry. Healthcare is a big field when it comes to 3D printing. You're talking about dentistry. I just got my tooth removed a couple of days back, and I noticed my dentist had a 3D printer. I was like, what's this? And he was trying to sell me a mouth guard. He said, I can print you a mouth guard. So yes, we are seeing printers like in dentist's office, everywhere we're going. But you talked about FDM being more of a personal printer. You also talked that you said you had 60 printers, 60 FDM printers. There are other technologies like SLS technology which enables you to print more parts per print on an industrial scale. Do you think that's going to get traction? Do you think that's better than having 60 FDM printers? How do they compare on an industrial level?
Let me answer. Then when you move in FDM, as I was saying, just from my point of view, it's not targeting the industry. It's again just for fun, for design, for even fashion. But if you want to move to industry, yes, you need to upgrade yourself a little bit. And then you come with SLS in polymer, SLM in metal. Yes, compare this technology with FDM, we need to have 60, then the same 60 machine they can produce 1 or 2 SLM. The question today is again, really market is driven by the costs. Then FDM is very cheaper. Then when we move, I can print globally, but I will be less costly. Then with SLS, I will be faster and I can produce more, but high technology, it will be a little bit high price. Even the raw material I'm using is a little bit different from the FDM. Then yes, I can print more with different technology like SLS, but when we go on cost, FDM is getting more popular, more used because it's cost effective and cheaper. But again, they target two different industries, two different applications. With SLS, I can print part, go in my car, go in the train, go in the plane with any problem, and we have the right certification. In FDM, really, I cannot see a part print in FDM can go in a car, okay, in automotive components. And this is a big difference.
Well, you said, I'm aware you have an SLS printer, and you're the expert in it. But just as Pierre explained FDM printers, I love the analogy you gave. Like, could you, in one sentence or two sentences, explain SLS printers for us?
Yeah, SLS printers, the big difference and how to print it, it's starting with the powder phase. Then we have our cake, it's layer after layer where we put the powder, and usually it's 100 micron, and we use the scanner, the laser or scanner from the top to scan our surface to print. Then it's going up layer by layer and again in vertical way. It's easy and fast. And the funny thing, because you have a cake where you will take the printer parts and you recycle all the powder and use it and to make it sustainable again. It's green process.
I'll take 2 points here. So the first is like Mr. Hedrick said, that you want to explain how is FDM different than SLS, and if I have 60 FDMs, why would I need SLS? So first thing first, it's like comparing apples with bananas. They're all used. So we can say, let me just simplify it. So if you say transportation, that is 3D printing. Now using a car or using a motorbike is different technologies, is FDM or SLS. I don't really consider anymore 3D printing as a technology. I consider it as a method of manufacturing. But that's why 3D printing is the wrong word. So that's where we start from. So additive manufacturing is a method of manufacturing. And in there, there's technologies. So the FDM is a technology, SLS is a technology, polyjet is a technology. The fancy word we talked about, what was it? VM? Wow. VM is a technology. So these are technologies, and they're all different from each other. The process, the material, the tech, the mechanics in SLS is completely different than what is in FDM. So 3D printing and additive manufacturing is a method of manufacturing. And under the umbrella, we have FDM, we have plenty now. We have, I can say uncountable. There's so many now. So many you don't even know about. They're in the lab right now. So now we're coming back to the topic of SLS and FDM. So FDM is a technology where there are FDM technologies that are doing industrial and grade parts, and we're doing also. So it is about the materials you use in there. So again, FDM has, let's say there's a company called Robols. You know Robols? So they're doing end-use parts which are competing metals in applications. So they're replacing metals with the high-grade polymers. So they're polymers, they're plastics, which are carbon-reinforced ABS, which are 27 times lighter in weight than metal printed parts. So plastics are going ahead in terms of application drive because they're easier to produce. When it comes to SLS technology, now SLS technology starts from industrial grade polymers. FDM has a wide range of materials, so starting from PLA, which is 50 or 60 dirhams kg by the school, that anybody can afford in their homes and schools and colleges, and they can produce some like funny parts or some hobby-related items. And then there's the defense sector that is using high-grade FDM technologies like robots. We talk about automotive. I mean, companies are using the whole bumpers produced out of FDM of automotive vehicles. The interior dashboards we have done ourselves and for the cars. Then those technologies about how you post-process after the print is done. And many times ready-use parts from the machine you're producing. Similarly, in SLS, in SLS, you have starting from industrial grade polymer. And it's expensive technology. It is only used for some certain applications where high grade temperatures are required, high strength is required, more engineering specific applications are there. So that's where SLS is.
So SLS and FDM. FDM is more on the personal side. SLS is more on it's definitely on the industrial side, but there is an overlap between them. let's say on an industrial scale, let's say there are new companies out there that are willing to start off with 3D printing on an industrial level. Do you advise they go with an FDM or an SLS?
It all depends what you want to do on it. So it depends on application, right away. First thing is always application. So on an industrial scale, you can have normal prints made out which are used for indoors. Let's say we use for one of the developers here in Dubai. They use for their toilet fixtures and their like door fixtures, and all items are in the buildings right now. So those are FDM printed. Not fancy material, they're ABS material or PETG materials. We're using them every day. So it's about, particularly it comes down, crunching out to application. So even if you're industrial scale, there are FDM farms. And defense companies, I personally know, there are defense companies who are doing end-use defense products. Now defense is a high-grade engineering application. They're having FDM farms. And they're using every single day as we speak for the end-use parts. So depending on application. So if an industry is there, it's always best option to have SLS for industrial application, but then you need a lot of SLS machines for that, and it's high cost of investment. So it depends on a lot of factors to decide which technology you want to pursue in your particular application.
Yeah, I think the same. There is no technology better than another. It always depends. What do you have to do? Okay. So for this reason, it's very good to know what is additive manufacturing and what are the technologies. And what I always say is, before buying a technology, use a consultancy. Ask some expert. Okay? The expert can help you to introduce the best technology for your needs, because not in general, for your needs. So even doing this kind of meetings is very helpful.
Absolutely, absolutely. And I'm loving the information that's coming out of this panel. Applications is a key word here. You talked about, very interestingly, you gave some very interesting names of brands, luxury brands, both in car manufacturers as well as fashion. What technology do you use in those applications when we're talking about top-notch luxury?
Yeah. So, for example, Italian automotive. Okay, so Ferrari, Lamborghini, Ducati, they have all printers because for some bumpers, for example, they use SLS. For the internal parts that it's visible, they use polyjet. For some other part that it needs very strong parts, but it's not visible to the person, they use sometimes FDM. So in this kind of industry, they have all kind of technologies. Fashion, like Prada and Gucci, as I told you before, they have polyjet technology because it's full color, okay? And the surface finish is perfect. Healthcare industry, polyjet again, and FDM. FDM because, for example, for printing bones, but not printing bones and put it on the body. No, it's only for surgical, again, for surgical simulation. FDM, it's enough. It's very good material. So,
can you give us an example on the fashion side of an example of a product that you printed with a particular technology that you thought was quite interesting?
If you write Gucci, Topolino is Mickey Mouse, it's in Italian. Gucci, Topolino, you will see it's a bag. It's 3D printed with the PLA. So I hope no one is recording.
It's an FDM technology.
There is another company, fashion company that prints bags, okay, with FDM.
So it's an FDM. Technology that you use with a PLA material.
Correct. FDM. Yeah. Let's say the cost of the bag is around €5. That is 20 dirhams.
Wow.
Yeah. Then of course it's hand printed. It's hand painted. So of course the price increase. They add also the name. Okay, you are recording, but okay.
You're giving the real value here.
The same bag is sold for $1,500. Okay. Of course you pay the brand, you pay because it's hand-painted.
But that's interesting because from a business perspective, it's a really feasible technology. I mean, if you are able to print products that are going to be a profit margin, it's interesting.
Because
I want to add here, remember we did some bags for Dior? Okay, how many pieces? We did Dior bags made out of flax material. So they were flexible against flax material.
yeah, but because here
I hope you were selling them in the Dior stores.
No.
I wish.
in this case, it's not mass production. Okay, so for some, yeah, correct. For this reason, if you ask Fiat, for example, because we have Fiat cars in Italy, there are no 3D printed parts in Fiat cars because it's mass production. If you ask in Lamborghini or Ferrari, that it's not mass production, but it's customized production, they have more than 500, 600 3D printed parts, only one car. So it depends.
You know, that's an interesting point. I think, Murad, you mentioned that when you first started, you said not everything can be 3D printing. We were having that discussion earlier. What's that fine line? You know, as a service bureau peer, you get people coming to you all the time saying, print this, print that. How do you decide this is printable, this is not printable?
Sometimes, it's funny to tell you that. So sometimes I get a call at 11:30 in the night. So my number is on the website because I enjoy taking calls and talking about 3D printing all the time. I want my team to take rest after 6 p.m. So usually I get calls from a mom saying, can you 3D print a Barbie doll arm which is broken? And sometimes some lady calls me and says, my jug of some user machine is broken, can you 3D print that? I'm like, no. I mean, we can, but it's not we're supposed to. And we get these kind of requests all the time. Somebody just called me and said, can you 3D print zebra crossing? I'm like, do you really understand what 3D printing is? Like there's something wrong there. So, I mean, if you come across and say 3D printing this, 3D printing that, you can actually do everything. There's nothing there that you cannot 3D print, but then at the same time, you want to see what is feasible. So, usually one big problem that I see in the market and on the news and everywhere is that they try to compete 3D printing with high volume. Oh, we can 3D print this bit. Although 3D printing, Product 21, we have 3D printed the largest 3D printed model in Middle East and Africa. Like we have done that, if you go to Dubai Mall, and if you see Adidas showroom near the ice rink, the whole 32 meters long facade is done by us. But I don't brag about it. The reason why is maybe it's not a good idea to do that. We did it because Adidas needed it. But the whole point of sharing this information is that 3D printing is not to compete with other technologies. It's a very common practice by the journalists or people who write blogs. So 3D printing is not made for larger scale models, number one. It is not made to compete with retail products. It is not made for high volume production. 3D printing is for the low volume, like if you want to have how many Ferraris are on the road, how many Lamborghinis on the road. So only like a high value, customized, low volume. That's the area where 3D printing is useful. Like I said, useful. So you can use it at other places, but that's where it stays.
So you wouldn't consider it a disruptive technology, it's more of a complementary technology to current
Correct.
practice.
So yeah, it shouldn't be compared with injection molding. Like injection molding, you put up a mold, and then you have to print the same size, same shape, same design for 1 million pieces. Whereas 3D printing, you can have 1 million pieces, have different names written on it, and still the price is going to be the same. And pricing in 3D printing, usually we get calls from a customer saying, Peter, we're ordering 5 pieces, but now I'm ordering with you 500 pieces. Will the price change? It doesn't change much. I mean, because each and every item is produced from scratch, layer by layer. Whereas on the traditional methodology, you have one mold or one design, you replicate it throughout, and it helps. So it's a...
Well, as I agree with Pierre, I mean, obviously it has a specialist area within the manufacturing field. But within that area, how quickly do you think additive manufacturing is growing? Do you think in those specialist area companies are adopting it very quickly? Are they hesitant, resistant to it?
Let me say, And back when I started in 3D printing almost 15 years ago, and really was just in the university in some high laboratory, and even the big industry, they were hesitating, skeptic to see this technology moving in the production chain. Today it's completely changed, everyone is talking about technology, even in the university, everyone talking in the media, even in the blogs. Then my expectation, I was telling you early, really in the next 3-5 years, in each school we will have a 3D printing. The new generation will move because now everyone at home has started 3D printing. They print, you can put at home papers, color, laser. Then imagine everyone at home tomorrow will have a 3D printing when you can print your tools. You need something for your kids, for your birthday, for any anniversary. You can print it at home, and you can make it personal. What you need today is you have the competence, skills, and this will come by education system. Schools, they will teach the new generation, my kids, your kids, how to do it. And then soon we will have really common. Everyone can easily say, okay, let's print something for tomorrow. And this will be adopting. And in parallel, we have a lot of new materials coming. The technology become very easy, very reasonable price, very safety. This is another topic I would like to mention because we mentioned a lot of this technology, but again, it's really, when we talk about industry, we need to really take in consideration a lot of aspects for the environment, for again, personal uses. And if we make it really plug and play for everyone, then we get what we are looking for. And everyone can use to it.
Vito, we are in Industry 4.0, the fourth industrial revolution, right? How do you see Industry 4.0, IoT, robotics, you mentioned robotics earlier, how do you see that influencing 3D printing?
Yeah, so what I see every day, that now 3D printing is very easy. Okay, you only have to do the 3D design, and you have to edit in the software and play. And the printers, let's say, do everything alone.
Is it really that easy?
It is. Let's say it is. It is, okay? The problem now, not a problem, but right now what is happening with 3D printing is that after the print is done, we need a human that needs to take out the part from the printer, need to do some post-processing. So it's half automated, 3D printer, and half not, because human. So what we are doing is using robots that also with artificial intelligence can take the parts. They can, with vision, they can see the parts, and they know if it's good or not, if they can keep the part or not. So, and they also can put the part in the sanding machine and in automatic. So, of course, that's good.
And then you can connect all of that to ChatGPT for customer service, and you go on vacation.
Correct. There you go. So, it's good from some point of view, okay? But I think the people in the future, what will their job be? So,
I was thinking a human would be more efficient than a robot doing that, isn't it? Like taking away the part and then post-processing it and quality checking it. I mean, a robot is cost a lot.
I think, technology has a cost, yes, but that cost is going to go down. That's an interesting
That's
question.
going to take like, I don't know, 30 years.
With 3D printing as of now, do you think the cost is going to go even further down, or do you
That's a
think
standard. So, I mean, you apply this to any technology, it's going to happen. But then, at the same time, you need to see what's feasible. So, okay, this is good for R&D, but not application at this moment, because robots are still slow. Except the robots that they do in the one company, Boston Dynamics. So that's the only company that does a robot that can flip. They can do the backflip.
Yeah.
So what I'm trying to say is that those robots are for defense industry. And when it comes to real-time applications, these robots are going to get very expensive at this point of time.
I personally think that the future of 3D printing is similar to what happened with the car industry in the past. Everything was made by hand, and now everything is automated. So with 3D printing, that's a new technology. In the future, we will see a lot of automation.
I would like to share one interesting topic here. So our 3D printers are 3D printed. So our 3D printers, the 60 machines, the Prusa printer, they're 3D printed. So a 3D printer it's funny that it can 3D print itself. so it can have babies. So a 3D printer it's a human, it's a epitome of a innovation or disruption. There's a first self-replicating device ever made. So let me explain the concept. There's a whole PhD theory on this. So imagine you sent it's very interesting. So imagine if you sent a robot to space, let's say to Mars, okay? And when it goes to the Mars, it starts producing more robots. And then those robots combined produce buildings. So when an astronaut goes there in the future to live, he's going to go and live in a society that's already built. So a 3D printer can produce 90% currently in my lab. It produces 90% of the parts, except electronics. And then electronics 3D printers are in the progress. So imagine what's going to happen then. I don't know where we're going, guys. So the chat GPT is going to go there, and then you have 3D printers that can 3D print themselves, and those 3D printers are now 3D printing buildings, and they're going to be 3D printing more 3D printers. You can have you can drop them in a Sahara desert, and they build a whole society out of it.
If you think printing printers is crazy, there's research of printers that are intelligent enough to print printers that are better than themselves. So there's evolution of the printers automatically. I mean, and that's a whole new level. I mean, but let's stay within the realms of reality. Let's talk about materials. I mean, we mentioned materials, here and there throughout the discussion. 3D printing, it started from prototyping, right? Where we just want a shape. And now, I think it was mentioned a few times, we're printing functional parts. So how did the materials evolve over time, and where are we now? What's the latest in materials, Murad?
The technology is really moving very fast, driven by the new materials. And I already mentioned earlier, today it's the industry demanding high-spec material because they have a high expectation. And as Arkham was mentioning, we don't need to mix up additive manufacturing. We need to bring value on the doctor. And we can make it faster, we can make it lighter. And the industry is demanding even better material. Today we can print high composite material. And I was mentioning, maybe no one knows, but 87% of the implants are 3D printed for medical application. Then because people take it in 80, 90, 100, and even more. And our bones are not created to get longer, and we need this implementation. And additive manufacturing is helpful in this respect. We are different, people from east to west, with different age, or different nationality, they have different spec in their body. And additive can fulfill the requirement, and new material can make it suitable for the body. That's the idea. And this is going on also in polymer side. Another aspect, we can print ceramic. And this again, let you know how we can push the technology to have better impact in the industry. And I'm sure soon we'll find new materials. Peter was mentioning where soon they can make organs. We can replace, we have all different diseases. And if the machine can print, your liver for you, or any part of your body, again, this will make the industry perfect. And everyone will be happy to replace any parts because they know they can rely on this technology. And something I like also to mention, this technology has with different integration. We mentioned with 4.0 because we can really match with different devices. I was talking with a friend that the new iPhone will have a function when you can scan any part, send it, and can be printed. Then everyone will be used, and everyone can take a picture. And these pictures can be easily created, filed, and be printed. Then this is what makes the technology very suitable, and the integration will be very fast for any day use life.
You want to say something, Peter?
Yeah, I want to share one quotation here. I read it like 3 days ago on TikTok. Did not come from the continuous improvement of candles. I'll read it again. Electric light did not come from the continuous improvements of candles. So what I want to say is that, what is the next step of a bicycle, if I can share? Like, it's 2 wheels, it is a paddle, and a handle, and a seat. There's no more innovation there. A chair, it has to have 4 legs, 3 legs, 2 legs, and a back seat, and a seat to sit. There's nothing else can add up there. A rocket, it has to fly. I mean, what I'm trying to say is that there's a limit to what a certain technology has to reach. And then you have to think about some disruption. So currently, 3D printing is about additive manufacturing, is layer on layer process. Now you need to fasten it up, okay. You will just, what else we can add there? The only thing that we can improve in there is materials. So the materials, currently, the most research that is happening in materials is in plastics. Because of the ease of use in the additive layer process. Whereas metals is showing a lot of, I was asked like 4 years ago when I started the company, when are you going to invest in metals? I was like, I'm not sure yet because I don't see any confidence coming from metal manufacturers for now. The same question is now for me, and the same answer is because metals have some sort of lot of challenges. Although once those challenges are outperformed, they're gonna change a lot of things in our daily lives. But at the moment, the most research and improvement is happening in plastics, and they're evolving crazy. So like I said, they're plastic that is stronger than steel. Yeah. And so imagine a flight, a plane. There are 4 forces acting on it. There's a weight, the force for lift, that's with the plane's wings, and then drag, that is aerodynamics, and then thrust, that is with the jet engines. These all factors are, 3 of them are based on the weight of the plane, and weight is based on the materials used. So if you reduce the weight of the plane and have the same strength, imagine how cheaper the flights are going to be in the future. So plastics are doing that. They're replacing metals, and that's a future effect.
Vito, I mean, we're talking about materials. They're obviously important because they are the final product that you're going to hand over to the customer. What thought process goes into selection of materials during the design? Do you sit with the customers and talk about the materials? Is there properties you're looking for? What do you consider a high quality material?
Yeah, so here again, everything depends
On the application.
And the first thing we ask is if some forces are involved. So in this case, we have to use some plastic instead of another. We have to know the heat of if the temperature has to be very high or not in this application. Because if it's low temperature, we can use standard plastic like ABS. If it's high temperature, we have to use, for example, urethane material. Or for example, if we have to 3D print parts for aircraft, for example, Boeing use more than 2,300 parts made by FDM. Material that the only material that in case of fire, it auto extinguishes, and at the same time, the smoke is not dangerous for the passengers. So again, everything starts from what I have to do. What's the end scope?
Well, we're reaching the end here, so I'd ask the audience to get their questions ready. I'll ask maybe last couple of questions. Murad, you're the expert on polymers. Can you talk to us about the applications of these two, how they compare to each other? Which one do you recommend, and for what applications again? In a short time, maybe.
No, the question we're always listening to our customers, to the industry, what they're looking for, what their needs, and how we can help them. Then it's our target to go to the customer and to have a good portfolio material. At the moment, I'm talking on the SRTIP side where we have a wind for material with almost a dozen of different material, from carbon fiber where we have very light, very strong. We have flame retardant material for some application. We have a sealing material for oil and gas application. And offering all different material, we can help and provide better solutions for customers. And again, we can target from medical to automotive to any industry. Then it's difficult to tell you today which material can be fit in any industry, because when you have big names, really they need maybe 4, 5, 6 different materials. And easily you can find in a car they use 10 different materials because they have different applications and materials. You need something aesthetical, you need something functional, you need something for your battery, then you need time redundant materials. It's really case by case we need to address the customers. And of course we have one technology with different materials and then we can be more competitive in the market.
Thank you, Murad. The last question I'd like to address here with, I think it's the most important question of today's session. I have a statistic here from a 2019 survey that says that 8,000 tons of 3D printed plastic went to landfills that year alone. With the problem that plastics has currently on our environment and in the world, and with the climate change issues that is quite devastating as we see from the natural disasters around the world, do you think, as the panel has agreed upon, that polymers is what's moving the fastest in the market, do you think we should continue, can we afford to continue pushing polymers? And how sustainable is 3D printing in that regard?
My background comes from a village back in Pakistan. And I was very close to the nature. We are agriculturists. And one thing I knew in the start of my career in 3D printing, that I'm going to print a lot of plastic. And once I saw that YouTube video, maybe Facebook video, where a turtle was having a straw coming out of his nose, it was a devastating experience. And I was a little boggled, like, this is again, I'm going to print a lot of plastic all my life. And I met one gentleman called Ronnie Tour. He's a UK-based entrepreneur, same as me. We started the journey of our companies at the same time. And he has a company called Filamentor. So at the early stage of that company start, he started with industrial recycled plastics for 3D printing. So what he's doing is that he's producing his filaments for 3D printing out of recycled industrial plastics. So the waste of industries, he's producing filaments out of it that are used for 3D printing. On the other hand, when we talk about the carbon emissions of 3D printing, so we 3D printed around 1,000 pieces, and he made a facade in the Dubai Mall for Adidas. Can you expect how much will be the cost of Deva charge for electricity, approximately? Like, can you estimate? With 2 months of printing going on. 2 months, 60 machines. No, not 60 then, 35 machines. 35 machines producing 1,000 parts in 2 months. Imagine how much will be the Deva charge for it. It was 652 dirhams. Because the FDM printer, it runs on 5. It's like maybe consuming similar power of iPhone. You know? So what I'm trying to say, I know plastics are used and that we need to reduce it, but then what plastic are you using? Are you producing new plastic to produce the parts, or are you using existing plastic that is going in landfills and using that to produce new parts? And the most interestingly, the FDM technology particularly, not the rest of the technology, but the FDM technology, when you have 3D printing plastic printed part, you can recycle it, make a filament and print again. And I have a current project going on, I have a current vision of doing that, inshallah, in 2021. That we will be able to have failed prints. So first of all, you're not having any waste material in the process of additive manufacturing. As of, if you have block of material, you cut down and you have a waste of material, right? That is not easy to recycle. In 3D printing, you don't have that. But if any print fails, you can again use it. So they are granule-based 3D printers now. So there is a lot of positive future for that. But at the end of the time, I cannot justify it, like it's plastics. But then, if you compare it in a holistic view, like consumption, carbon emissions, what technology, you can have a solar-powered FDM lab. I'm also planning that with in Joseph Ruby, recently, my partners, they recently have solar-powered factories running, and I'm thinking to power my whole lab of that 652 dirhams out of solar. So it's a holistic view if you see it. It's fine.
Thank you for that, Peter. Lots of questions, lots of discussions, but I'd like to give the audience an opportunity. Do we have any questions from the audience? Yes, please.
My question is from the educational perspective, that I feel like at the early school level we expose kids to 3D printers and get them excited about manufacturing. But I feel like at some point we lose them along the middle school to high school pipeline, and they're not given guidance of interesting careers on the manufacturing side and how to get involved in projects. And then at the college level, we've already lost them, and that's why we have so many kids interested in like software and tech entrepreneurship. They interpret very narrowly in terms of apps and stuff, but they don't know a lot about these opportunities. For example, I'm visiting the Middle East at the moment, and I see lots of interesting things in software, but until I saw this event happening, I had no idea that there was interesting stuff happening on the manufacturing side as well. So I'm interested in your thoughts about what is missing in the education system right now, whether it's specific to this region or even in the rest of the world where software is so far ahead of mechanical engineering and other related technologies. Where are we losing kids, and what would you like to see happening to improve the educational pipeline here?
I have an education background, so I used to train about 3D printing and schools. That's where I started the whole thing, and I know exactly what you're talking about. So when I started my journey, I was doing with the GEMS school. I've given training courses in GEMS. I'm training courses at MIT universities. Most of the universities are doing courses on 3D printing for the younger kids, as young as in robotics labs in Pakistan. That's what we used to do. It is, I mean, if I say, so let me say, it's about the educational structure, the institutional structures that are built, that are old school. Basically, they spend more time on the classrooms, the old ones. Now they're improving, of course. You see 3D printers in there, you see software in there, you see robots in the schools these days, the robotic kits like Lego and stuff, you know. So they're getting interactive, but at the end of the day, it's about the children. What's more attractive for them? They are attracted to the iPads. You can't beat it. They are attracted to the screens. They're not attracted to sports as what it was before in our times. I was never attracted to sports either, but I'm just saying. Since a childhood, I was making things of carpentry and what I'm doing now. But I'm just trying to say that this is more of interest of children, what they find more interesting. Of course, it's boring for them, many times. It's about, some children, they come up crazy. Like, I had a small kid who ended up, he was honestly 7 years old, and they are printers specifically made for them, which are safe, which are not too much heating. They have certain process of printing. There's a software called Tinkercad. They can design it. It's so simplified. It's not complex. I mean, they used to make beautiful stuff. We did a project for Expo 2020. We did 300 models, 300 kids from ages from 6 years old to 15 years old came up to us with a sketch and a concept in mind, and the 3D design and 3D printed it was displayed at Expo 2020. I was the project director of it. It was called Young Innovators Program. Now, those kind of programs, when you integrate, will help. In the early stage, instead of giving them a course, get them design and print. Instead of the talk over here for students, I'm saying, for general public it's fine. But for young students, they need a personal time, and that comes from the parents. The most of the time children spend is in home, not in school. And these things come from their parents, from their family, where they want to direct them. You want to screen time. I've already started using it for my future kids. Maybe if I don't do it, they're not going to do it. So I use the new tool of the iPhone, which has a screen time of Instagram, TikTok. I was addicted to TikTok. I was spending 1 hour in it. So I want to reduce it, and you want to give them Legos. You want to buy them machines instead of buying them toys. My father always gave me engineering sets when I was young. I had a huge collection of Legos. That's why I became what I am today. I don't know. He was in carpentry. He was in sketching. He was in photography. So that's where I'm coming from. So it's about what tools you give them. It's not about the school and courses. That's not going to help them. It comes from the family. So if you buy a 3D printed ticket in your home, for example, they're going to make use of it. They're going to learn, okay, software, that is to be trained. They have to have a course in school that is provided to learn 3D design. But to make it 3D printable, it is about, it comes from personal touch. You cannot teach that. It is a skill, very high skill, that needs to be, integrated in the early life from the holistic view, like from not only school, but from the both together. That's what maybe I'm wrong, but I'm not expert at education, but that's what my experience says.
Yeah, let me interrupt. I just saw the CEO of the park saying, I want to invite him, then he can give a small talk with the audience.
If you can finish in 30 minutes.
Let's say anything. We will be happy to join.
part, and we are really glad to have you here. And I understand you are all from Portugal? Slovenia? Brazil?
Pakistan.
Pakistan. Okay. So welcome to the park. Is this your first time in UAE, or and you are here to explore the country? Business and explore the country? Okay, good. I was trying to read the names, but it was all in Portuguese, so I couldn't tell. But I see there are some coaches among you as well. So you are in which business? Luxury? Business, finance, coaching, automotive. So you're in the right place. UAE is very diverse country with a lot of activities at the moment happening here, and the country is 50 years old, 52 years old, I think, and it used oil to really develop the country and bring it to where it is today. But the rest of the years, the country wants to focus on technology and R&D, on knowledge. So we are a government institution mandated to do that. So we have a strategy for the government, and part of that strategy there are enablers. There are different technology projects in the UAE, and different institutions trying to push this drive. We are one of them. Here in the park, we focus on different areas. Production, design, and architecture is one area that we focus on at 3D, and when you have a visit and you see our facilities, then 3D technology, we are very proud of it. And we are also lucky because we are surrounded with more than 22 education institutions. So the biggest educational city in maybe the region is here. So all what you see when you come is all universities and colleges and colleges, and that's what for us is very important because it helps us with our innovation drive. So it's an exciting time for us. We have different technologies here. We have 3D printing, we have things in the transport logistics, we have agriculture, we have digitalization. Of course, I just touch on the people, we do all of this, of course, for us to transform from oil-based country to knowledge. We need a lot of coaching, we need a lot of change in mindset, because people are used to more of a service industry. Now we have to change them into something else. And to do that, of course, we have to bring. Can you hear me? I have water in my ears, and I can hear myself, but so I'm worried about shouting because. So and we're trying to see how we can also mobilize new technologies to bring and create new industry. And fashion, for example, is one area that we are really trying to see how we can use 3D printing for fashion. So when you go around, you will see small samples. And if you are in fashion, I think this is an opportunity. Really, maybe the people here they can tell you. But I feel there's an opportunity because Dubai anyway is really a center for fashion, and I don't think anyone is doing it really. So we at the American University of Sharjah, this project is actually owned by the American University of Sharjah, and we have a big architecture school as well, and there's a big drive for fashion as well there. So we're trying to merge between these industries and between businesses as well. Bottom line for us is really to create business. And of course we try to tackle different elements, but it's really good time here in the UAE now. We are a bit biased for you. We feel we are becoming a center of the world. There's so many things happening, and the visionary leadership we have, they've invested in the infrastructure, so we are ready to go into the future. I've been to Portugal many times. I think I've been there last year as well for the Web Summit. There's 2 Web Summits this year, May in Brazil, and there's also November, I think, in Portugal, probably will be there. The Web Summit, yeah. So I just wanted to say welcome, and I hope you will enjoy your time here. And if there's any question, I'm happy to answer before I leave. But thank you very much. Number 1, 2, 3, 4. One? Okay.
I'm Brazilian, Barbara Marques, and I was thinking about the future of my son.
Yes.
Because I see a lot of dads and moms giving smartphones, tablets.
Happy Mother's Day, by the way.
For your son's babies, like 1 year old. And I think my son is not like this because I prefer Lego and smart toys.
Yes.
Because you can develop your intelligence, your mindset, and so it's very, very nice. I'm grateful for being here today, and thank you.
Well, thank you very much. I think this is an issue everywhere, to be honest, around the world. People have concerns. So what we've done here is we have the slabs here. You will see it. We're trying to get people back to really using their hands, because this is really. We had the Director General of the Intellectual Property, World Intellectual Property Organization here a couple of weeks ago, and he was telling us, focus on industries. Okay, online business is good, mobile apps is good, but it's not sustainable for any country, because any time they can pick up their labs and go to, as you go to Hawaii or somewhere else and work from there. But industries and things like this stays in your economy. So this is something that we want to develop and focus on. How can we develop our industries more? Because Sharjah used to host 40% of the industry in the country here. But now we are trying to see how we can use those technologies to take industry to the next level. And we have some nice examples in our lab. I think you can see. Right.
I want to ask you, now when you talk about industry, I think additive manufacturing does add a lot of cost reductions for industries, like when you talk about defense, right? In maritime, oil and gas, energy production, right? So they stock a lot of inventory for parts, so they have ready to use when needed, right? With additive manufacturing, they can kind of have streamlined production of spare parts when they need it, right? So they don't have to spend all that money in inventories. But what we see is that the adoption really of industry, of certain areas of industry, is very low, especially for critical parts, because they don't trust that additive manufacturing is capable of replacing the traditional way of manufacturing, right? Of subtractive manufacturing. Do you see what are the challenges? What is needed for certain? Because I think technology it needs to be forward-thinking, but it needs to be practical. Industries needs to see cost benefits. They need to see performance benefits. They need to see better materials. They need to see the benefit to implement, let's say, to be really a disruptive technology, right? And it is nice to see all these applications that have no idea about, but what we see is that there are certain areas that they just don't trust that additive manufacturing method, for example, can replace a one piece. How do you see, what do you think are the challenges in how research, innovation, and maybe industry joint projects can demonstrate that additive manufacturing can be a solution that can replace typical manufactured parts, can be cost effective, as you said, right? And can streamline businesses. They can save money by doing these things, but it seems like there is something missing.
Yes,
because it's
absolutely.
just not happening, right?
I agree with you, because I don't have background in additive manufacturing, but the first thing we've done here, when we started this, we said we wanted to have a quick wins. And everybody was talking about 3D technology. So I said, the first thing I will go and do 3D. So we work with a 3D construction. So we built a villa, printing 3D, and we want to go more. And then I've been talking to the gentlemen this, and they know. We talked to GE, and we brought metal technology, 3D, now have plastic. It's not straightforward in my opinion.
Yes.
It's not straight. And I think this is not for a mass, in my opinion. Maybe in certain areas it's for mass, but and a lot of it is more specialized. And I think there is different geography or different entities can use it in a different way. I think in the UAE we have a chance because we are not an industrial country. This is expensive, I think sophisticated technology. It's not easy for anyone to get. But for a country like we, which is small, with not a lot of packages to carry, I think we can do something in this area, and I think we're already doing it. In oil and gas, maybe in space. You know, we have in Al-Ain a company called Strata. A lot of body parts of Boeing and Airbus is actually done here in UAE using 3D and additive manufacturing. And this company, Strata, which is part of Moderator, 70% of their employees are all females engineers, local. Yes. So it's a very, very interesting company. And they actually do parts for Boeing and Airbuses now. So I think there's no one size fits all. We are trying to find our way, to be honest, with these gentlemen working and everyone here to really find out. But I think there are some industries that are advanced, like healthcare, for example. So yeah, that's what I think. Right.
Well, I'm an industrial engineer, so I love everything that you said. It was really interesting, so thank you very much. Well, since I was doing my studies in France, I know that we had a lot of projects with 3D printing, and then I also participated in food challenge. And what I also have in my mind, I know that the raw materials, they're expensive, and they also tailor-made, as you said. But one thing that I had in my mind, it was like, is it also studies in the area of food industry? Because like for me, my dream would be to have like a microwave where I could buy my materials and then we could print my own food as like a Michelin star, or I don't know, like anything with flavors, with smells. I know it's nothing with what you're talking to, but because you talk to travel to Mars and everything, so I said, okay, I would like to ask about this. It's also studies in this sense because okay, luxury, also the electronics, and we have a big crisis for Audi in semiconductors, so it will be our dream come true, like to print some chips. So I would also ask about the food industry, if there's something foreseen, or do you know some studies that I can realize my dream to have a microwave?
I think that you've seen in the news people printing burgers or things like that.
No burgers.
What do you want?
Yeah, I want I want to have a microwave where I can like put my raw material, and then they will bring up whatever I want to eat, you know, because you said about the light.
Well, I don't know. I mean, I think they can answer, but I think really the sky is the limit. I think with technology, what you can do, and I think this place is a place where we try all of these things. And to do this, of course, you need champions. I think the technology is there, the knowledge is there. Just you need someone with a drive who can, you know, drive these ideas. But you never know. I think things are changing rapidly now. So. Yeah, we can answer you maybe after the session. But anyway, I really want to say thank you very much again, and I hope you enjoy your tour here, and good luck with your trip as well.
Thank you. Thank you a lot, gentlemen. I think you all, I hope, all enjoy this session today and know more about all the possibilities of additive manufacturing. And I think here, yes, it's the right place. There's a lot of things happening. So thanks a lot for your contribution today, for all this interesting insight. It was really, really interesting. Thanks a lot. I think we can really applaud all. Sorry, yes.
Yes, I also have a question. The same as the lady. Actually, I want to ask her, you're just hungry.
I'm not hungry, I had a big breakfast. But I wanted to ask about the food. When you mentioned skin printing and from the cells, so how can we print maybe meat? Like, you know, they grow meat in the labs, so can we print meat and food and stuff like that? What do you think?
The food industry is really moving. One sector is chocolate. There are a lot of, I come from Belgium. I was living in Belgium, one famous store.
Yes, food industry is another
like sectors where this technology is moving a little bit slow as expected because it's very customized products, but I was involved in a project where they print chocolate. Because again, people they like to see the shape of the food, then you can think, with the basic Mickey Mouse or make it extra too. Talking about other industry, there are, I know already reality, there are in the market they're selling it. It's Israeli company, they make vegan meat. When people, you have a stick, but it's vegan because it's printed. Then the shape can be normal or can make shape of the chicken, but it's vegan. Then it's a big demand for the market, again, to be healthy, to be sustainable. People, they are moving a little bit in this direction, where again, they use the minimum, material, and again, in this case, it's really the cells you need, or again, they can compromise because people do, they have a different diets. Someone, they need more protein, someone needs more carbohydrate. Then there are technology where they can combine your diet and they can give you the shape what you're looking for, they can eat it. Then it's moving there. Again, it's not there to have the microwave, maybe it's the movie of 5 Elements, where they put the design, they put the bottom and you have the lasagna or you have the pizza.
Is it possible the 5 elements to print the body even?
There's a question.
Yeah, I think it's moving. Maybe in 5 years we sit down again and we have this microwave with us and we can demonstrate that it's absolutely coming.
And everyone knows that the future of the food are insects. Correct? Insects.
I don't know.
This is the future of
I
the
don't know
food.
what
Yeah,
is
you
you
can
want
read
to
it.
ask.
It's the future of the food.
Are you offering the service? What service?
Yeah, so that you can get in the future.
It's not just insects, it's insects and algae as well, because it's the easiest to grow. but just to answer your question, Google gastroprinting. It's a big field, and it's beautiful. There was an event in Dubai. It's good research.
I want to add here to your question. You see, that's where I've been doing 3D printing past 10 years now. And I've heard about 3D printing organs, 3D printing food. 3D printing is everywhere in my life. So, at the point, it's like, enough. So the reason is because it's good for the fun part, but it's never going to give you a taste of the real food. I have eaten a 3D printed chocolate. It doesn't taste like a chocolate. And they have a 3D printed pizza that I have not tasted, but I'm pretty sure it doesn't taste good. Because see, what you get out of a stove, the same taste wouldn't be coming out of a printer. Unless, recently we did for Pati. Is it an NDA? Okay. Pati is a famous chocolate brand in UAE. We made molds, food grade molds, 3D printed out of it. Now see, that's an application here. So you're not making the chocolate itself, but you're making a mold that you can have a Burj Khalifa shape of chocolate. You can have Mercedes came to us for the G-Wagon chocolates. We made them actually. Not for Pati, but Mercedes. So they had a chef, they brought a chef. The small G-Wagons, they're like very famous because they ran a driver here. So they're very famous in UAE. They had a small chocolates or G-Wagon. Whenever you buy a G-Wagon, they give you a small box of chocolate. And that is because of 3D printed food grade mold. So when you say food is straight from the printer, I mean, possible again. But then again, do you really want that? You know what I mean? It might be good if you're in Mars and you want to try pizza. Because they cannot bake a pizza, so they can 3D print a pizza. And there's a 3D print pizza concept coming for the future space station. Astronaut lives there for 6 months without a pizza. I don't know. I cannot live without a pizza for 6 months. So it's that kind of a thing. I mean, it's not going to taste same, and some applications are not made for 3D printing. So that's what I think of food. Would you want that food it's coming out of a machine with chemicals and things? You want to go more vegan, not say vegan, but you want to go more organic. But the food processed from a machine can be organic. It have to go with certain temperatures and things like that. So it's not going to be, I don't know. It's just like when you think about it, going to that direction.
I'm thinking about what you said about electrical lights.
Right?
I'm thinking about what you said about electrical lights that does not come from candles, so it's something that does not exist, but it might be in the future.
Yeah, so there's a concept. I was with a PhD professor in Germany. He has designed, and I hope that comes in the world, he has designed a kiosk, a top kiosk for medicine. So you see, there's one big problem in our society, that a Panadol is used for everybody. But everybody's temperature, everybody's requirement is not the same. The protein, you know, there's a very famous medicine for the proteins and vitamins for everybody. Like there's a company. Now imagine you walk into a kiosk, the ingredients of different medicine, and it takes your blood sample and quickly tells you what you require, and medicine is produced for you. That is possible with 3D additive manufacturing. A layer of certain chemical, a layer of certain chemical, and a layer of certain chemical. If somebody of you can work on this concept, make it true, he's going to be a billionaire in the future. So imagine a customized medicine for you. So 3D printing is for customization. That's where it is useful. Maybe you can say a customized pizza for certain patient. Yes. Because it has those ingredients made for that person. So that's where it is useful. Again, don't forget, for additive manufacturing, low volume, just like our CEO said, in UAE, it's not about the quantity, but quality. The population is 9 million UAE. That's why 3D printing is most of the boosting here. So it's about low volume, customization, and rapid requirement. That's where the 3D printing comes in the whole genre.
I think also, you know, the technology is fluid, so we cannot say, I mean, you know, we don't know where it's going to go. Should we wrap it up? I think we have gone a bit over time. Thank you very much for my esteemed panel. It was lovely having you here. Interesting discussion. Thank you everybody for doing this. Thank you.
Thank you, but I will keep